we shall continue our discussion about regular expressions. So regular expressions represents regular languages So what are regular languages? It represents a language, but we call it as a regular language. What are regular languages? These languages are precisely accepted by finite automatons. So in some sense, finite automaton accepts set of strings. We call it as a language. In particular, we call it as a regular language. Why it is named a regular language? Set of strings accepted by finite automaton can be expressed succinctly using regular expressions, using operators such as union, cleanage star and concatenation. Since we are able to come up with a regular expression or a succinct way of representing this set, it gets the name regular language, and it is also related to the class of languages accepted by finite automaton. So given a regular language, one can realize a finite automaton with epsilon moves. Without epsilon moves, a deterministic finite automaton, one can also come up with a regular expression for the same. Fine. Let's explore a couple of examples. Language can be empty set because it is a set of strings. Language may contain simply this, an empty string epsilon. This is an empty set. This is not an empty set. It contains one element, namely empty string. And language could be set of strings, say ending with B, not containing AA. So something like this. Language could be set of strings such that number of A's and number of B's are even. So something like this, one can list many. And for each of them, one can come up with a finite automaton. For example, for this one, we say a state and no final state at all, which means it accepts this. Or it could even be a two-state automaton, say this, and you see that there are no arrows from Q0 to Q1. Or you can even say Q0, Q1 and no arrows from Q0 to Q1. And anything of this accepts empty state, this accepts empty set, this also accepts empty set. And the regular expression corresponding to empty set is empty set itself. So RE for this is empty set. This one, if the start state and final state are same, then we get to see that it accepts empty string. So the regular expression corresponding to this language is simply empty string. Now on the similar line, we want to explore for questions like this. So this one corresponds to the language, this one corresponds to the language containing this. Now on the similar line, let's explore set of strings ending with B, not containing AA. Let's look at this set. It says set of strings ending with B, so just B is allowed, and not containing AA, which means just A is not allowed, AB is allowed, AA is not allowed, BA is not allowed, and BB is allowed. So as far as two length strings are concerned, the possibilities are AB and BB. Let's look at some more patterns. So I can have sequence of B's, that's allowed, and after reading a B, one can read A, but after reading A, one cannot read any more A's. The next one cannot be A. So which means, meaning sequence of A's is not possible. And the next symbol cannot be A, so it has to be B. And it is still ending with B, not containing this. After this, it could be sequence of B's. And then I may read A. If I read a A, I am forced to read a B next. So that's the point. Whenever you read A, the next symbol has to be B. That's fixed. Correctly, yeah? Because if the next symbol is A, we get this pattern which is not allowed. So which means AB is the pattern. Whenever you read A, you are forced to read a B next. It cannot end with A also, because it says strings must end with B. Which means you will have something like AB, AB, AB. In between, you may have something like so many B's, and before that also you can have so many B's. Correct? So whenever you read A, B must follow. Correct? So which means when you have AB at multiple places, and in between you can have B's. It could be just AB, it could be just B, or it will have pattern like this. Of course, it can even begin with AB and followed by some number of B's, then AB, followed by some number of B's, and if required, another AB. So this is precisely the pattern we get to see as far as this set is concerned. Correct? Now which means it is B or AB. It is that is playing the role, nothing more. Correct? And AA is not possible, and BA, it cannot end with BA, so it can only end with AB. And if you have BA, then A must follow B, so it becomes BAB, and you still have B and AB in the pattern. Correct? So which means the focus is only on these two patterns, and they appear in some form. Correct? So what is the simplest possible string? It is B or AB. So it can end with B or AB. And what is that we can have before this? Before this, it could be any number of B's or any number of AB's. You can also have AB, AB, AB so many times, and any number of AB's. So which means I will have star for this. So this clearly tells you, if you take 0 from this, because this is 0 or more copies of B plus AB, if you take 0 from this you can take either B or AB. So you generate B. If you get AB, you get this. If you get so many B's, then from this you can take B or AB. Fine. If the string is going to be ending with B, then you take a B, and if there are, say, n B's, n minus 1 B's come from this, nth B comes from this. And if you have so many copies of AB, then last copy comes from this, rest comes from this. If the string is going to end with AB, then take AB from this, rest of them we can generate from this. So this clearly tells you that here is a regular expression for the language containing not containing AA and ending with B. So this is our idea. You have an infinite set and we wish to express using a finite or a succinct expression called regular expression using operators such as concatenation, union and star. And the advantage of this is what is represented by this expression is accepted by finite automaton. So the class of languages accepted by finite automaton are regular in nature. The reason being they have an underlying regular expression. Now we know how to construct a finite automaton for this. So we start from Q0. The simplest string that we can accept is B, or we read A, and after reading A we read a B. Correct? So we can do this. Now in addition to that, we need to fill this part, correct, which we shall fill now. So the easiest way to fill this part is the epsilon NFA is helping us. So after reading a B, come back to Q0 on epsilon. After reading AB, come back to Q0 on epsilon. Now either you read B or AB and stop, or after reading a B you come here and read some more B's, or after reading AB you come back on epsilon and read some more B's or AB's, and you continue this pattern. One can also obtain a DFA for this. For example, Q0, on reading a B we go here, on reading A we go here, followed by a B. This is what we are. Now after reading this B, one can read any number of B's. We still ensure it is ending with B, but the moment we read A, we are forced to read a B. Then after reading this B, we can read any number of B's, and the moment we read A, we come back and read a B, which means after seeing this AB, one can read couple of B's, then read another AB. You may want to read some more B's, yes, and then come back to this. And this will ensure the pattern ends with AB or sequence of B's. Similarly, you may get just sequence of B's followed by AB or just sequence of B's. So now from this AB is defined, from this AB is defined, from this if A comes, then it should go to an empty state or dead state. On this you read AB. From this AB is defined. So one can also get an equivalent DFA by employing NFA without epsilon followed by subset construction. Now the idea is the following. You have set of strings and that is accepted by finite automaton, could be NFA with epsilon or deterministic finite automaton. Can that set be expressed in some succinct form? That's precisely this. Okay, let's explore some more questions like this. Consider this set of strings over A comma B, starting with AB, ending with a B, and the length of the string must be even. So now for this we wish to construct a regular expression, subsequently NFA with epsilon transition followed by DFA. let's look at base strings. So always what you do, you look at base strings and with that try developing other strings, then you get to see a pattern, and once you identify a pattern, you can bring appropriate operator to express what we want. So it starts with AB, it ends with B. Now the question is ABB allowed? No, because it says it must be an even length string. So which means the minimum possible string is 4 length string. So this one could be A or this could be B. So these are all our base strings. Anything below is not possible. Now apart from this, now you have AB and somewhere B comes. The next one is A, or it is AB, B, it ends with this. Now in between is what we need to analyze now. Remember, base string is this, so which means this can be epsilon, you still get a 4 length strings. And overall it is even. Overall it is even. And this part is even. 3 plus 1, this part is even. So naturally, this one must be an even length string. Correctly, yeah? So this must be an even length string. This must be an even length string. But do we have any constraint on this? It could be any string. Any even length string over A comma B. This can be any even length string over A comma B. The simplest string is a 2 length string. Possible values are AA, AB, BA, BB. And after that, the next even length is 4. That 4 will be 4 A's, or maybe AA followed by AB, or BA followed by BB. Like that it goes up to all this. Which means, if you look at this even length string, and this even length string, you pair them, you look at them 2 at a time. If you look at them 2 at a time, then where do they come from? They come from the set AA or AB or BA, BB. It cannot be anything, right? It has to come from this. And you can have any combination of that and any number of times. So which means it is AB. The third one is A or B. And it ends with a B. In between, it must be an even length string. It could be AA or AB or BA or BB, and this you can do any number of times. So there is a star for this. So this gives you 2, this gives you 1, 3, this gives you 1, 4. So you get the base string. In between, you will have to generate even length strings. So which means this one generates all even length strings over A comma B. You take any even length string and you group them, you pair them. You look at AB, BA, BB, AA. Then if you pair them, it is AB, BA, BB, AA. So which means you can generate from this and you can repeat this. You can have AA, BB, AA, BA. Again it is AA, this. Which means a star introduced to this will give you even length strings over A comma B, and this satisfies what we want. That's all. So if you carefully observe the pattern by looking at the start, end and the third symbol, then you get the base string. Then you just have to separate this part and this part, and that says it could be any even length string. Interestingly, any even length string can be generated using this expression. Therefore, the regular expression corresponding to this language is precisely this. Now one can construct an NFA with epsilon followed by the corresponding DFE. So always focus on base strings and strings that can be generated out of the base strings and extract a pattern. You may get some questions as well. For example, how do we generate all even length strings over A comma B? This precisely gives you this. Now one can also generate all odd length strings over A comma B. So if you want to generate an odd length string, it will either begin with A or B and followed by it must be even, so which means it is AA, AB, BA, BB whole star. So this generates odd length strings. So if you remember pattern like this, you can plug in at appropriate place and complete the question.